So first you have to upload the firmware to the device. You can run this command. It's compiling, uploading. While it's uploading, it will be off, so that's normal. Usually when it starts, it has default configuration, so the servo moves. And currently it displays temperature. The letters are a bit cursed, but hopefully you can understand them. Temperature is 25.8. And now the moisture. Obviously the letters are bad. 40%, that's nice. And CO2, that's 648. And well, that's showing. We can show you our pull request. So when we make a new pull request, in this example we are changing some data in temperature and humidity. It's a small bug fix. And when the pull request is made, it tries to compile it. If it passes, then the pull request is accepted and we can merge it. When the pull request has been merged, it runs another action. One is compiling and uploading as an artifact, and the other one, if anything with Docker is changed, it will upload a new Docker image. Here it also compiles with Platformio, and in the end it will upload as artifact so we can make it as a release or something else. It contains source code and the firmware. And that looks to be done. And we go to the latest thing. And here we can see the artifact with all the data. And now we wait for the uploading for backend. While we wait, the green light shows that the connection is successful, and red lights basically mean that it's on. So, yeah. Longest 5 minutes of my life.
Oh yeah.
And now we can see that the blue light is on. It's sending. It's blinking because it received data. We saw that the servo moved. So that means that it's out of bounds. So obviously servo moves to do something. For example, open a window, ventilation, or something like that.
Alright, so we got the backend server running with a Docker file containerized on the Google Cloud Run. And the server runs non-stop and receives data from the IoT device and gets requests from the front end.
Okay, and on the right we have the connection, which is done through WebSocket. Here we have the default WebSocket connect async method that is being used. We also display a message to see if we connected. Afterwards, we process the data after receiving it. And in the receive loop async, you will see that we are calling another method called process receive data, where we process the bytes that we receive. Here we get a string of data. First we check if the data in the checksum has the CMD identifier. Then we create the new object, a measurement object. We have some exception here just in case. After that we have the send data periodically async method, which sends data back to the IoT device. Here we have the method. Then we just send the preset that we created using a preset DAO. Here we can check the active preset as well. And both of these tasks are being monitored by a task when any. So basically, when any of these complete, the method will cancel the other one out, and then it will start both of them back again. And when processing the measurements, we have a measurement converter class here, which helps us do that. We basically receive a string of data and we create a new byte array out of it, which is at the half of the length of the string, because in the string each value is represented by two numbers or letters, and then we run through it with a for at the pace of 2. We can see here that it has plus equals 2, and then we say the position on where the new value should be saved in the new array. Then we convert it using this operation here, data substring, and in hexadecimal format, and then we will shift the value of the most significant bit by 8 steps to the left, and then we will OR it with the least significant bit here, and then we will divide the final value by 10. And we also add some exceptions here in case something happens, so we can debug it easier. All of these are being saved inside a database. You can see here.
A database that is hosted on the cloud, where we store all the measurements and all the data from the IoT device, but also we store the users created from the front end.
The database is also written in Postgres, and it was made using like EF core migrations. But as my colleague before me mentioned that we connect to the front end, we also have some RESTful APIs. 2 seconds. We also have a REST endpoint for each of the 3 entities we need: users, presets, and measurements. Let me go into measurement API, as that is what we were talking about. We have some simple getters here that get all of the values depending on get all after a time stamp. So anything after a specific time frame, it's going to return that through to the front end.
Okay, when you open up the application for the first time, you are greeted with the sign-in page. As a new user, first of all, you go to don't have an account, sign up, where you then create an account. You put in a name, here we have demo45, an email address, which has to include the @ sign and end in a common domain, for example, .com or .dk. Then you put in a password, you confirm said password, they have to match actually. When you then press sign up, both get sent to the database, and you are thrown back to the sign-in page, where you then input the email address from before and also the password. Yeah.
After signing in, backend sends the token to frontend, and that token allows the system to read the data. We have at front 3 latest data, and then here we have a chart where you can switch the units, and also zoom in and out from the data. It's not, like this. And we have a profile page, graph page, where you can see individual graphs and also zoom in to look at the data further.
Yeah. Well, next we have the profile page, and in the profile presets, because our project it's aimed for multiple use cases, we decided to be able to create your own desired range for humidity, CO2, temperature, and of course how much you want the servo to move. Well, I have created here 2 profiles. For now, I will show you what happens if you create a new one. For example, I will create one with the same values, but just replace the 2 with 3. Afterwards, I'll just go down here and create it. Now, I have created another one, and if I want to modify it, for example, I want the servo to not move 50, but I want it to move 70, for example, I will just press save. Every time a request is happening, being it a post request when you create a profile, a put request when you modify an existing profile, or delete, because right now I will try to delete the newest profile I made. It goes back to the database. Of course, you need to still have the token for authentication, and I will switch from example 1 to example 2 here by making it active, which sends back to a put request back to the backend, where it tells the servo which values are the currently one that they should look for. And I should briefly talk about the DevOps pipeline a bit. So I will log out, and now this is the pipeline that we have used for the front end, and I will show 2 examples. For example, this one is a failed one for our bugfix2 branch, and as you can see, it failed because it's unable to find an element on one of the tests. And then this one is testing the same, but it's of course for another commit, and it has passed all the tests it had. So therefore, is being afterwards built a Docker image and pushed on Docker Hub. And that's about it.